Control flow in Go. Question: what is the init statement in an if condition in Go, and where can you use its variables? In Go, you can put a short initialization statement before the condition in an if statement. You separate them with a semicolon. Any variable you create in this init statement is only available inside the whole if and else chain. You cannot use it outside of the if or else blocks. Question: what is the shadow variable trap in Go when using an init statement? The shadow variable trap happens when you use the short declaration operator inside an if statement. The new variable with the same name, like air, only exists inside the if block. It is a different variable from the one outside. When the if block ends, the inner variable disappears and the outer variable is still there unchanged. Question: what loops does Go have? Go has only one loop construct, which is the for loop. It does not have while, do while, or for each loops. You use the for loop for everything. Question: how do you ignore values in a for loop in Go? You use an underscore to ignore values you don't need. For example, you can ignore the index and keep the value, or ignore the value and keep the index. If you want to ignore both, you can just write for range followed by the slice. Question: where is the loop variable accessible in a for loop? The variable you create in the init statement of a for loop is only accessible inside the loop. You cannot use it outside of the loop. Question: what is the range copy trap in Go versions before 1.22? In older versions of Go, when you use a for range loop, the value you get is a copy of the original item, not the original item itself. If you try to change that copy, the original item in the slice stays the same. To fix this, you should use the index to access and change the original item directly. Question: what was the loop variable capture bug in Go versions before 1.22? The bug was that when you created a function inside a loop, it captured the loop variable, but all the functions ended up using the final value of the loop variable, not the value at the time they were created. To fix this in older versions, you had to create a new local variable inside the loop. From Go version 1.22 onward, this is fixed by default, and each function gets its own copy of the loop variable. Question: what do break and continue do in a Go loop? Break exits the innermost loop immediately. Continue skips the rest of the current loop iteration and goes to the next one. What is special about the order when you loop over a map in Go? When you loop over a map, the order of the items is random and changes every time you run the program. If you need a consistent order, you must collect the keys, sort them, and then loop over the sorted keys. Is it safe to loop over a nil slice or nil map in Go? Yes, it is completely safe. If you use a for range loop on a nil slice or nil map, it does not cause a panic. The loop simply does not run any iterations. What happens if you modify a slice while looping over it? The range expression is evaluated only once at the start of the loop, so if you change the slice itself, like taking a new slice from it, the loop still uses the original length. But if you change the elements themselves, it depends. For a slice, you are looking at the original array. For a map, new keys you add during the loop may or may not be visited. Question: which is faster when looping over a slice of large structs? Looping by index is faster. When you use a for range loop that gives you the value, Go makes a copy of the large struct each time. When you use an index, you access the original struct directly without copying. Question: how does a basic switch statement work in Go? Answer: a basic switch statement in Go lets you check a variable against different cases. For example, if you have a variable called day, you can check if it's Monday and print start of week, if it's Friday, print almost weekend, or if it's Saturday or Sunday, print weekend. If the day doesn't match any of these cases, the default case runs and prints midweek. Question: what is a switch statement with an init statement in Go? In Go, you can have a switch statement with an init statement. This means you can declare a variable right before the condition. In the example, the code gets the operating system name and stores it in a variable called OS. Then the switch checks the value of OS. If it's Darwin, it prints Mac OS. If it's Linux, it prints Linux. If it's something else, it prints the operating system name. Question: what is a tagless switch in Go? A tagless switch is a switch statement without a variable to check. Instead, it checks conditions directly. This is a cleaner way to write long if-else chains. In the example, the code checks a score variable. If the score is 90 or above, the grade is A. If it's 80 or above, the grade is B. If it's 70 or above, the grade is C. If none of those are true, the grade is F. How does Fallthrough work in a Go switch statement? In Go, switch statements do not automatically fall through to the next case like in some other languages. Instead, you must use the Fallthrough keyword on purpose. When you use Fallthrough, the next case runs even if its condition is false. In the first example, if n equals 1, it prints 1. Then Fallthrough makes it also print 2. The Fallthrough does not continue to case 3. In the second example, the first case is true, so it prints first. Then Fallthrough makes it run the second case, even though that case condition is false, so it prints second. Question: what is a type switch in Go? A type switch is used with an interface to check the underlying type of a value. In the example, the function takes an empty interface, which can hold any type. The switch checks the actual type of I. If it's an int, it prints the integer. If it's a string, it prints the string in quotes. If it's a bool, it prints the boolean. If it's a slice of integers, it prints the length. If it's nil, it prints nil. If it's none of those, it prints unknown followed by the type. Can you match multiple values in a single case of a switch statement in Go? Yes, you can match multiple values in a single case by separating them with comma. This is useful for grouping related cases together. For example, you can put all success HTTP status codes in one case, all client errors in another case, and all server errors in another case. This makes the code cleaner and easier to read compared to having separate cases for each value. If any of the values in the comma-separated list matches, that case runs. Question: how do you use labels with break in Go switch? In Go, a normal break inside a switch only exits the switch statement. If you need to break out of an enclosing loop, you can use a label. In the example, there is a loop with a label called loop. Inside the switch, if the command is quit, it uses break with the loop label, which breaks out of the for loop entirely. But if the command is skip, it uses a normal break, which only breaks out of the switch and continues with the next iteration of the for loop. Question: what is a select statement in Go? A select statement is like a switch, but for channels. It waits until one of its channel operations can proceed. In the example, it tries to receive from channel 1 or channel 2, or send a value to channel 3. Whichever channel is ready first, that case runs. If none are ready and there is a default case, it runs the default and does not wait. Question: how can you handle a timeout when waiting for a channel operation in Go? You can use a select statement with time.after to handle timeouts. In the select block, you have one case for reading from the channel normally. Then you add another case using time.after with a duration, like 3 times time.second. If the channel doesn't receive any data within that time, the timeout case will run, and you can print a timeout message. Question: how can you cancel a worker function in Go using context? You can use a select statement inside a loop to check for cancellation with context. The select has 2 cases. One case listens to the context's done channel. When the context is canceled, this case runs and you can print a message and return from the function. The other case receives values from a regular channel and processes them. This way, the worker can keep doing its work, but also stop when it gets a cancellation signal. Question: how can you check a channel without blocking in Go? You can use a select statement with a default case. For receiving without blocking, you have a case to read from the channel. If there is a message, that case runs. If there is no message, the default case runs immediately instead of waiting. For sending without blocking, you have a case to send to the channel. If the channel is ready to accept the message, it sends. If the channel is full or not ready, the default case runs. This lets you check channels and continue with your program without getting stuck. Question: what happens when you use an empty select statement in Go? An empty select statement with no cases will block the current Go routine forever. It never returns and just waits indefinitely. This is useful in the main function when you have other Go routines running and doing all the work. You can put an empty select at the end of main to keep the program alive without doing anything else. Question: how does a nil channel behave inside a select statement in Go? A nil channel is never ready for sending or receiving, so in a select statement, any case that uses a nil channel will never be selected. The select will ignore that case completely. This can be useful if you want to disable certain channel operations temporarily. You can set a channel variable to nil to turn off that case, while other cases can still run normally. Question: how can you dynamically disable channels in a select loop? You can set a channel to nil when it's closed to disable it in the select. In this pattern, you have a loop that runs while any channel is still open. Inside the select, you receive from each channel. When a channel is closed, you set that channel variable to nil. This makes the select ignore that case forever. The loop continues with the remaining open channels. When all channels become nil, the loop ends, and you can close the output channel. This is useful for merging multiple channels into one. Question: what are some common pitfalls when using select in Go? There are several pitfalls to watch out for. First, using select with a default case inside a for loop can create a busy loop that spins the CPU and wastes resources. Second, calling time.after inside a loop creates a new timer each time, which can leak memory. It's better to use time.newTimer and reset. Third, a break statement inside a select only exits the select, not the surrounding for loop, so you need to use labels or return to exit the loop. Fourth, nil channels will block their case forever, which can be useful as a feature, but might also be a bug if you don't expect it. Question: how does the Goto statement work in Go, and what are its restrictions? Go supports Goto, but with strict rules. You can use Goto to jump forward or backward in your code. It is sometimes used for cleanup when errors happen. However, Goto has important restrictions. You cannot jump over variable declarations, because that would skip creating the variable. You cannot jump into a block, like an if statement or loop, from outside that block. You also cannot jump between different code blocks. These restrictions help keep the code structure clear and avoid confusing bugs. Question: what is panic in Go, and what causes it? Panic is a built-in function that stops normal execution of a program. You can call panic yourself with any value, like an error message or a number. The runtime also automatically panics for certain problems. These include dereferencing a nil pointer, accessing an array index that doesn't exist, sending on a closed channel, and type assertion failures when you don't use the "OK" form. When a panic happens, it starts unwinding the stack and running deferred functions until the program crashes or recover catches it. Question: how does recover work in Go? Recover is a function that only works when called inside a deferred function. It catches a panic that is happening and stops the program from crashing. When you call recover, it returns the value that was passed to panic. If there is no panic happening, recover returns nil. This lets you handle panics gracefully and turn them into regular errors. In the example, if dividing by 0 causes a panic, the deferred function catches it and sets an error return value instead of crashing. In what order do deferred functions run in Go? Deferred functions run in last in, first out order, which is like a stack. The last function you defer will run first when the surrounding function returns. So if you defer print first, then second, then third, the output will be third, then second, then first. When are arguments to deferred functions evaluated in Go?
Arguments to deferred functions are evaluated immediately at the line where defer is called, not when the function actually runs later. So if you defer a print with a variable, it prints the value the variable had at that moment, even if you change the variable afterward. If you want to use the current value when the deferred function executes, you need to use a closure that captures the variable itself.
Question: why is it dangerous to use defer inside a loop? Using defer inside a loop can cause resource leaks because deferred calls don't run until the surrounding function returns. So if you open many files in a loop and defer closing them, all the files stay open until the whole function ends. This can exhaust system resources. The fix is to wrap the loop body in an anonymous function. Then the defer inside that function runs when the anonymous function ends, which happens each loop iteration. This way, resources get cleaned up immediately. Question: how can a deferred function modify the return value? When a function has a named return value, a deferred function can access and modify that value. In the example, the function returns n, but the named return is called result. The defer runs after the return statement, but before the function actually exits. It multiplies result by 2. So even though the return says n, the final returned value becomes n times 2. This works because the deferred function has access to the named return variable. Question: how can you use defer with recover to handle panics? You can use defer with recover to catch panics and turn them into errors. In the defer function, you call recover to check if a panic happened. If recover returns something not nil, a panic occurred. You can then set an error return value with information about what happened. This lets your function return a normal error instead of crashing the program. The division operation that caused the panic runs first, then the deferred recover catches it before it crashes. What are some common and useful patterns for using deferred in Go? There are several common defer patterns. For file handling, you open a file and immediately defer closing it. For mutases, you lock and defer unlock to ensure it always releases. For timing code, you record the start time and defer a function that prints the duration. For HTTP responses, you defer closing the response body. For database transactions, you defer a function that checks if there was an error to either roll back or commit the transaction. These patterns help ensure cleanup always happens, even if errors occur.
Question: when should you use panic versus error in Go? You should use panic only for truly unrecoverable situations. These include programmer bugs like nil pointer dereferences, impossible program states, or configuration errors at startup. Panic means something is badly wrong and the program cannot continue normally. You should use errors for expected failures that a caller can handle. These include input validation problems, I/O errors like file not found, and user mistakes. Question: what is range over function iterators in Go 1.23? Go 1.23 introduced a new feature called range over function iterators. This lets you create custom iterators that can be used with the range keyword. An iterator is a function that takes a yield function and calls it for each item. The yield function returns a Boolean that tells the iterator whether to continue. You can then use this iterator directly in a for range loop. This makes it easier to create reusable iteration logic for custom data structures or iteration patterns like going through a slice backward.
Question: what are the iterator signatures in the Go iter package? The iter package defines two main iterator types. Iter.seek takes a yield function that receives a single value. This is for iterating over one value at a time. Iter.seek2 takes a yield function that receives two values, usually a key and value pair. The yield function returns a Boolean. If it returns false, that means the caller stopped the loop, and the iterator should stop. This lets you create clean, custom iterators that work with the range keyword and can be stopped early by the caller. Question: what standard library packages have iterators in Go 1.23? Several standard library packages now include iterators. The slices package has all for index and value, values just for values, backward for going through slices in reverse, and collect to turn an iterator into a slice. The maps package has keys for map keys and values for map values. The strings package has lines for iterating over lines in text. These iterators let you use the range keyword with custom iteration patterns directly from the standard library.
Question: how do you create an infinite loop that runs periodically in Go? You can use a ticker with a select statement inside an infinite loop. First, create a ticker with time.newTicker and the interval you want, like 5 seconds. Defer stopping the ticker to clean up. Then, in an infinite for loop, use select to wait either for the ticker's channel or for a context cancellation. When the ticker sends a value, you do your work. When the context is done, you return and stop the loop. This pattern runs your work every 5 seconds until the context is canceled. Question: how can you implement a retry pattern with exponential backoff in Go? You can create a retry function that takes the number of attempts, sleep duration, and a function to try. In a loop up to the attempt count, call the function. If it succeeds, return nil. If it fails and is the last attempt, return the error. Otherwise, sleep for the current duration, then double the sleep time for the next attempt. This gives you exponential backoff, which means waiting longer each time you retry. The pattern helps handle temporary failures gracefully. Question: how do you combine multiple channels into one using fan-in and Go? Answer: fan-in means taking multiple input channels and combining them into a single output channel. You create an output channel and a wait group. For each input channel, you start a Go routine that reads from that channel and sends each value to the output channel. When a Go routine finishes reading its channel, it signals done on the wait group. Another Go routine waits for all input Go routines to finish, then closes the output channel. This pattern lets you merge data from multiple sources into one stream that the caller can read from. Comparison: if-else versus switch. Control flow comparison table. Common mistakes. Supported range types. Expression switch versus type switch.